So here we've been given the area of a square, or 64 centimeters squared. So this area has 64 squares in it. Okay, and we want to find the side length. So we're going to go from the square area to the side length by square rooting. And again, try to understand that we are not dividing here to do this. We're undoing the square. So we're going to square root. So if I want to draw 64 squares in here, I need to have 8 along one side, 8 along the other, and by doing so I can get 64 squares in here. If I count it 1, 2, 3, 4, 5, 6, 7, 8, I have a side length of 8 centimeters to do that. Okay, so we can draw this and get that. However, and it's a perfect square, so it works out nicely that we can get a whole number side length. However, we can also use our square root operation on our calculator. So when we undo this square and square root it, we get the side length. Here, the opposite, we have a side length of 3, and I want to know the square area. So when I draw this out, clearly this is 9. And I can find this by squaring my 3 centimeters side length, and I get 9 squares. Okay, here the operation would have been I square root 64 squares, and I end up with the side length of 8 centimeters. Here, with a side length of 15 meters, I can find the area here, so that I can draw in 15 lines in here like this and then count it all up. That would be tedious. So I know that I can go from the side length to the area by squaring. If I square, I end up with the square area. So I end up with 225 squares inside this space. Here the area is 25. So in this case, I start with the area inside. I want to get the side length outside. That going from area to side length is square rooting. So I'm going to square root my 25 squares, and I should end up with a length of 5. Okay, and I can draw this in. If I draw 25 squares, okay, there's my 25 squares, and I can see clearly 1, 2, 3, 4, 5. My side length is 5. So here we can use our calculator. We can square these. These are perfect squares, so we can square and square root these. So here the 25 represents the number of squares inside a square. If I want to find the side length of that square, we're talking about a side length of 5. Again, we are undoing the square. We're not using divide in this case, although it can be done by division. Since we weren't given the answer to start with, we can't divide until we actually know the answer here. Okay, so what we're doing instead of dividing is we're taking area and finding side length. Inside the square root is area, so 64 is my square area. The side length of that square must be 8. If my square is 49 squares, the side length of that square is going to be 7. This is the opposite. If I square, I start with the side length, I square it, and I get the number of squares inside. So if I have my side length of 4, I can draw 16 squares on the inside. 9 squared is going to be 81 squares in the middle, so a side length of 9 gives me 81 squares. Here the side length is 5.5. If I square this, I'm going to end up with 30.25. I probably should use a calculator for this, but I should end up with 30.25 squares. The nice thing about squares is that we can, when we talk about squaring a fraction, we can square the top and square the bottom. Okay, so squares work on both the top, the numerator, and the denominator of a fraction. Okay, and the reverse is also true. If I square root this, I can square root the top and square root the bottom independently. Here my side length is 1/2, okay, and if I square that, I get an area of 1/4. This one's easy to show because if I have a square here and I only take 1/2 along the one side and 1/2 along the other side, okay, I can see that I have only 1/4 of area. Okay, so there's 1/2 length, 1/2 length. Okay, 1/2 squared, if I square that, there's my area. That's only 1/4 of a square. So 3/4 squared, I'm going to square the top, square the bottom. That's going to give me the area or the number of squares based on that side length of 3/4. And again, I can show this one here. If I have a side length of 1 and divide it into 3/4, okay, so there's my 3/4 here, and I can do 3/4 along here. Okay, so if I have a 3/4 side length and I want to find the square area, there's my square area. Okay, so if this is 1 by 1, this is an area of 1. If I want 3/4 square, well, if I only want the length of 3/4 and square it, I don't get the full square, I only get 9/16 of the whole square. So here if I square -5, okay, well, this one, it's useful to think of this with multiplication. If I square -5, we're going to say -5 times -5, which negative times negative is positive. So that allows us to know the sign, and we are going to end up with 25 squares. Here, 5 squared is equal to 25. Okay, so if I have 5 squared, it's going to be 25. Now, one thing we should make note of, I think I put a star there because really, if we look at this, -5 squared, and we compare it to -5 in brackets squared, these are different in that the square only affects the number directly to the left. This one is not affecting the negative. Here the negative is affected. So here what we're going to do first is square the 5 and then apply the negative. So that one works out to be -25. So it's important to make sure you understand this distinction between bracket squared versus just squared. And then lastly, -4 square root. Well, if I want to kind of try that, if I think of this in terms of multiplication, which I can always go back to multiplication to understand squares. If I think of two numbers that multiply to 4, well, that's 2 times 2. But I need to multiply by itself the same number, by the same number, and end up with a negative. So if I use -2 and -2 to get 4, well, that doesn't give me negative. If I use positive, well, positive times positive doesn't give me negative. So when I try to undo this square here, this is not possible with real numbers. So this is not possible. Or we're going to say it does not exist. Well, actually, that's not quite correct. This we'll just say we can't do for now. Okay, because this ends up into something that we call imaginary numbers, which you may work on later on in higher level grades.